Hello and welcome to another video. This is the fifth video in this series where we are discussing the important points or important questions related to the job interviews and exams for civil engineers. So this is the fifth video in our series. Till previous video we have discussed I think 10 points, and today we will further discuss 4 more points related to the important questions for interviews and for the exams of a civil engineer. So let's start today's video with point number 11. This is related to the densities of construction materials. So as we know that there are various construction materials used on a construction project or a construction site. These materials have their own densities. As a civil engineer, we must know the values of the densities of these materials. If not all, at least we should know the densities of very basic materials such as bricks, concrete blocks, and reinforced concrete. So as shown in this table, the density for bricks varies from 1600 to 1920 kilograms per meter cube. For concrete block, the density is 1920 kilogram per meter cube, and for reinforced concrete it further increases and there is 2310 to 2700 kg per meter cube. So these are very important densities of three important materials of construction project. So you need to know the densities of these materials, and you can go through the densities of other materials too, like bricks, cement, concrete, sand, reinforcement, glass, plastic, wood, tiles, as these are also very important construction materials. You will see the use of these materials on almost every project related to the construction. So as a civil engineer, you must know the densities of these important construction materials. The next important point for today's discussion is the, the diameter of the reinforcement bar to be used in a slab. As we know that the diameter of the reinforcement bar or a steel bar to be used in a slab depends upon the thickness of the slab. How thick is your slab? The reinforcement we are going to use in the slab, its diameter depends upon the thickness of the slab. So it is directly proportional. Actually, it is directly proportional. If the thickness of the slab increases, then with the increase of the thickness of the slab, you need to increase the diameter of the bar. So for that, we have a relationship, or you can say it as a formula to find out the maximum diameter of a bar we can use in a slab. So for that, we can use this relationship. There is 1/8 of the thickness of the slab. Whatever will be the thickness of the slab, you need to multiply that by 1/8. Then you will get the maximum diameter of the bar. So it is recommended that the dia of the bar to be used in a slab should not be greater than 1/8 of the thickness of the slab. So there is very important questions. You can see this sort of question in your multiple choice questions during your entrance exams or written exams. Either an interviewer can ask you this sort of question during your interview. So this is the maximum diameter of bar used in a slab. You can find using this relationship. And the third point for today's discussion is, this is very important point, very this is asked various times during interviews, during exams. So it is also important if you are a site engineer, because it is related to the concrete free fall. So the maximum free fall for a concrete is allowed. The height is 1.50 meters. The height cannot be more than 1.50. If it goes above 1.50, then what will happen? You can face the problems of segregation and bleeding in the concrete, as you can see in this image. Got it? If segregation and bleeding occurs in the concrete, at the end of the day, you will face the problem of honeycombing. You can see in this image, you can face the problem of honeycombing in the concrete. So you need to maintain the height up to 1.5 meter whenever concrete is freely falling on any construction site. As you can see in this image, the mouse cursor is showing that the height from here to this point should not be more than 1.5 meter. So the maximum allowed height for the free fall of concrete is 1.50 meter. If you will not follow this, then you can face the problem of segregation and bleeding and then honeycombing. So that's the important point. And the next and last point for today's discussion is related to water absorption of bricks. So a good or a higher class brick should not absorb more than 15%. Which brick we can call as a high class brick? If that brick is not absorbing water more than 15% by its weight, then you can call it a higher class brick. So it is recommended that the water absorption of a brick should not be more than 15%. Got it? But on average, the water absorption shall not be more than 20% by weight for other classes. But when it comes to higher class bricks, for higher class bricks, the water absorption of the brick by weight should not be more than 15%. Got it? So that's another important point. So this is the last point for today's video. Thank you for watching the video. See you guys in the next video. We will come up with more important points related to the exams and interviews of civil engineer. So till then, goodbye. See you guys in next video.